Let us see our next chapter is circles. What is meant by a circle? What are the properties of the circle? Let us we discuss in this chapter. Circle is a set of points equidistant from the center. Circle is a set of points equidistant from the center. That center is denoted with the O, and the fixed distance from center to a point on the circle is called a radius. Next, the line segment joining any 2 points on the circle is called a chord. A circle has infinite number of the chords. A circle has infinite number of chords. In the same way, a circle has infinite number of radii also. Next, in a circle, the chord which passes through the center of the circle is called a diameter, and a diameter is the largest chord of the circle. OA represented with radius, or OB is also represented with radius, represented with small r. The distance from center to a point on the circle is called radius. The distance from center to a point on the called radius. A chord which passing through the center of the circle is called a diameter. The largest chord is diameter. That is, diameter is equal to r plus r. Diameter is equal to 2r. That is, diameter of a circle is 2 times of the radius, and radius of the circle is half of the diameter. Next, a chord divides the circle into the 2 parts. A chord divides the circle into the 2 parts. The major part is called major segment, and the lower part is called minor segment. And XY is called major arc. Let us consider a point C. Let us consider a point D. Now, XCY is called major arc. XDY is called a minor arc. Next, XY, it is a center O. Angle in the major segment is acute. Angle in the major segment is acute, and angle in the minor segment is obtuse. That is, here theta is less than 90 degrees and greater than 0 degrees, and here theta is less than 180 degrees and it is more than 90 degrees. That is, angle in the major segment is acute and angle in the minor segment is obtuse. Next, angle subtended by major arc. Angle subtended by major arc in the alternate segment is, angle subtended by major arc in the alternate segment is obtuse, and angle subtended by minor arc, angle subtended by minor arc in the alternate segment is acute. That is what we learned here: major segment, minor segment. Angle in the major segment is acute, angle in the minor segment is obtuse. Next, angle subtended by major arc in the alternate segment is obtuse, and angle subtended by minor arc in the alternate segment is acute. Next, angle subtended by major arc, angle subtended by the major arc at the center of the circle is more than 180 degrees. That is, this theta will be more than 180 degrees. And angle subtended by minor arc at the center is less than 180 degrees. Now, angle subtended by the major arc at the center is more than 180 degrees. Angle subtended by the minor arc at the center is less than 180 degrees. Let us see our next topic, tangent. Tangent to a circle. What is meant by a tangent? A line segment which touches the circle. The line segment is a AB which touches the circle at the point P at exactly one point. Then the line segment AB is called tangent to the circle. A circle has how many tangents? A circle has infinite number of tangents. You can draw a infinite number of tangents to a circle. Next, the number of tangents can be drawn to a circle from a fixed point. Suppose this is a circle. Circle name is a C1. A point A is here. The number of tangents can be drawn to a circle C1 from a point A is 1 and only 1. I can draw only one and only one tangent from a fixed point on the circle. Number of tangents can be drawn to a circle is infinite. Number of tangents can be drawn from a fixed point on the circle is one and only one. Next, secant to a circle. Now, the line segment AB, the line segment L, this is a line L, in that one mark the point AB. AB is the line segment. This line segment AB intersect the circle at two different points. or two distinct points is called secant to a circle. Tangent which touches the circle at only one point, secant intersect the circle at two different points. Let us see the next concept. It is a circle with a center O and OA is the radius and OB is the radius. Now, the angle subtended by an arc at the center. The angle subtended by an arc at the center. The angle subtended by an arc at the center is double the angle at the remaining part of the circle. That is, the angle subtended by an arc at the center is double the angle subtended by the remaining part of the circle. That is, here 30 degrees is there. Suppose half of this one, here 15 degrees will be there. That is ABC. Now, we can write the relation between the angles. Angle AOB is 2 times 2 angle ACB. Angle AOB is 2 times 2 angle ACB. And next concept. What is meant by a cyclic quadrilateral? Cyclic quadrilateral. If all the 4 vertices of a quadrilateral lie on a circle, if all the 4 vertices lie on a circle, such one is called cyclic quadrilateral. Suppose see, A, B, C, D. If all the 4 vertices of a quadrilateral lie on a circle, then such quadrilateral is called cyclic quadrilateral, and the points A, B, C, D are called concyclic. In cyclic quadrilateral, sum of opposite angles is equals to 180 degrees. That is, angle A plus angle C is equal to 180 degrees and angle B plus angle D is equal to 180 degrees. That is, the opposite angles of a cyclic quadrilateral are supplementary. Now, let us suppose I join this diagram is like, now A, C, B, D is a cyclic quadrilateral. Now, suppose this angle is 40 degrees. The double of 40 is 80 degrees. Now, this is called reflex angle AOC, reflex angle AOB. How to find the reflex angle AOB is equal to, we know very well, the angle at the center of a circle is 360 degrees minus what is the angle occupied, angle AOB. That is, reflex angle AOC is equal to 360 minus angle AOB. That is equal to 360 degrees minus angle AOB is 80 degrees. That is, 360 minus 80, that is 280. That is, this is 280 degrees. Now, reflex angle AOC, reflex angle AOB, 1, 2. Now the third one. Now how to find angle ADB? This angle, how to find angle ADB? Angle ADB is half of reflex angle AOB. That is half into reflex angle AOB is 280. The half of is 140 degrees. Now, just we discuss that the opposite angles of a cyclic quadrilateral is 180 degrees. Now, let us check with example. 140 plus 40, 180. That is, opposite angles of a cyclic quadrilateral is 180 degrees. Next, from this, what is the angle of angle AEB? Fourth one, angle AEB is equal to 40 degrees. Reason, angles in the same segment are equal. Angles in the same segment are equal. If you draw as many angles, what's the angle? 40 degrees. Why? Because angles in the same segment are equal. In the similar way, if you draw an angle here, what's the angle here also? 140 degrees. That is, angles in the same segment of a circle are equal. And what we learn from here? The opposite angles of a cyclic quadrilateral is 180 degrees. Let us see next, angle in a semicircle. Now, diameter AOB is the diameter and O is the center of the circle, and ACB, C is a point on the circle, join AC and BC. Now, from our previous information, angle AOB is 2 times of angle ACB. Angle AOB is 2 times of angle ACB. But AOB is a straight line. That is, angle AOB which measures 180 degrees, since it is a straight line. Angle on the straight line is 180 degrees. Therefore, substitute in the above, 180 degrees is equal to 2 times of angle ACB. Therefore, angle ACB is equal to 90 degrees. Angle ACB is equal to 90 degrees. That is, angle in a semicircle is 90 degrees. Now, let us see ACBD. It is a cyclic quadrilateral. What will be the angle here? Now, here the angle is 180. Now, here the angle is also 180 because angle at the center of the circle is 360. 180 plus 180, 360. Therefore, the reflex angle is 180. That is, to get the angle ADB, half of reflex angle AOB. That is, angle ADB is equal to half into angle AOB is 180 degrees. That is, angle ADB is equal to 90 degrees. That is, here also angle is 90. Just from our previous knowledge, opposite angles of a cyclic quadrilateral gives 180 degrees. Therefore, 90 degrees plus 90 degrees is equals to 180 degrees. Let us see the theorem. The tangent at any point of a circle is perpendicular to the radius through the point of contact. The tangent at any point of a circle is perpendicular to the radius through the point of contact. We have to prove this theorem now. Now, let us consider a circle. Let us consider a circle with the center O, and AB be the tangent with point of contact P. Now join OP. We know very well OP is the radius. Given let O be the center of the circle. O be the center of the circle, comma, AB is the tangent. AB is the tangent with the point of contact. With point of contact P. RTP, to prove OP is perpendicular to AB. This we have to prove. Construction take a point Q on AB. Take a point Q on AB, condition other than P. Take a point Q on AB, there is other than P. Q. Now proof. Now O be the center of the circle. O be the center of the circle, comma, AB is the tangent. AB is the tangent, that is OP is equal to the radius. Now OQ lies on AB, OQ lies on AB, and it is other than P, that is Q lies outside the circle. Q lies outside the circle. Therefore, what we conclude, OQ is greater than OP. Now similarly, let us consider a point. Consider a point R on AB. Again, consider a point R on AB. Consider a point R on AB. It is also other than P, and join OR. Therefore, again R lies outside of a circle. Again R lies outside of a circle. Therefore, what we conclude for this one is, again OR is greater than OP. Collects among such points, what is such points? Q, P and so on. If you take Q or such points, among such points, OP is the shortest. Among such points, OR, OQ, OS, like. From these all points, OP is the shortest, which is possible only when OP is perpendicular to AB. Because perpendicular distance is the shortest distance. Perpendicular distance is the shortest distance. Therefore, we conclude that OP is perpendicular to AB. Therefore, we conclude that among all the points, among all such line segments, among all such points, that is, which is called among such line segments, OP is the shortest, and which is possible only when OP is the perpendicular to AB, because perpendicular distance is the shortest distance, that is, OP is perpendicular to AB, hence proved. Therefore, what we learned, radius is always perpendicular to the tangent, and vice versa, tangent is perpendicular to the radius.